And welcome all to Chapter 9. It's kind of sort of a little bit Lesson 6 called Scale Drawings. You should focus on vocabulary for the day, scale drawings, scale models, scale factors, and of course, scale. So focus for this particular lesson is to solve for unknown values. So let's say you have centimeters on a map, but inches in real life, and you know the scale is 1 centimeter is equal to 5 miles. Meanwhile, on the map, it's 2.3 centimeters from one city to another. Okay, can we find the actual distance? That is our goal for today. I think I'm going to split this up. We're going to do two different videos for the day. Scale drawings, the dimensions of a scale model or scale drawing are always going to be proportional to the actual dimensions of the real life object. Now, a scale drawing could be enlarged or it could be reduced depending on that scale factor. Of course, we have two examples here, the reduced photo of the cake and the enlarged photo of the cake. If you do a scale factor of 1:1, naturally that would not change anything. So generally, we don't have scale factors that are 1:1. Example here, distance between Daytona Beach and Orlando. Now we have a scale factor, it gives it to us. It's kind of hard to see here, but it reads that a half an inch on the map is really about equivalent to 17 3/10 miles in real life. So can we find the actual distance? Well, sure. First, we pull out our ruler and we measure it. And when we measure it, we find that it's about 1 3/4 inches away from each other on the map. Now you'll notice that we use that information to create a proportion. Always, of course, you guys know me, I'm always going to suggest write the units first, inches to miles, and then you fill in the numbers. 5/10 of an inch is equal to 17 3/10 miles on the map. So let's go ahead and substitute in 1 3/4 inches, and now we can find that missing piece. Of course, we know how to do that. We're going to use our cross products that are available to us to create an equivalent relationship. 5/10 times d, or 5/10 d, is the same as 17 3/10 times 1 3/4. Now, naturally, that's about 30. But we don't want to know what half of that d is, so we're going to go ahead and divide both sides by 5/10. And we will then find that the distance in real life is approximately 61 miles apart. All right, let's go ahead and take a look at a couple examples now. Half an inch equals 14 miles. Ooh, as soon as I see that, inches to miles, inches to miles. Now, for the sake of consistency, I'm generally going to keep the actual amount in the second part of the ratio. I almost said the denominator, but remember, we're not talking fractions, we're talking ratios. Now, that doesn't mean you couldn't change it up. You could do a relationship of miles to inches. If you recall, we talked about that in the last lesson, as long as you are consistent. But in this case, I'm going to go ahead and use inches to miles. We know that a half inch is supposed to be equivalent to 14 miles in real life. If you look at the map, it's 1.5 inches. And so the question is, how many miles? Now what we're going to do is we're going to take this and we're going to find our scale, or excuse me, our cross products. Now I don't know what a half times x is. After all, x is an unknown amount. But I do know that 1.5 14s is 21. Now, if I split 21 up into half segments, it would actually be 42. So, in real life, distance between those two cities is approximately 42 miles. Another one, another ratio. Here we're comparing centimeters to kilometers. And of course, they give us the scale factor. 1 centimeter is about the same as 130 kilometers in real life. If we look at the map, we see 5 8/10 centimeters. The question is, what is the actual distance? So we'll go ahead and once again use our scale factors. 1 times x, or 1x, is the same as 130 times 5 8/10. Now in this case, folks, guess what? It already says x equals. So all we have to do is multiply 130 by 5 8/10. I'll do that as quickly as I can. And provided that I did not rush, what we're seeing is about 740 kilometers apart. 754, excuse me. Here we go again. In this case, scale factor is given. We're comparing inches to miles. So the first thing we do is set up our ratio. In this case, 1/4 of an inch is the same as 2 miles in the town. Fire station and town hall are about 3 1/8 inches apart. Question is, how far are they really apart? We go ahead and we multiply 1/4 times x, and we multiply 3 1/8 times 2. And of course, some of you will notice, well, firstly, we don't know what 1/4 of x is. 3 1/8 times 2. First of all, 2 wholes written improper, 3 1/8 written improper. Now go ahead and cross reduce, make your life a little easier. And you'll see that it is going to be 25 over 4. Could you change that to a mixed number? Yes. But for now, I will choose not to. Why? Because we have to solve here for 1/4 of x. How do we solve and get rid of it? Some of you prefer going old school and writing divided by 1/4. And I want you to know that's perfectly okay. You come off to the side, you divide by 1/4. But listen, how do we divide by 1/4? We multiply that by the reciprocal. So some of us will choose to simply go straight to the multiplicative inverse. Now the reason that works, 4/4 cancels, 1 1, well that's still 1, that doesn't really cancel, but look what we end up with. We end up with a single x. In this case, 4 is also cross-reduce, and we end up with 25 wholes. No need for the 1, folks. After all, it's 25 whole miles. So just a reminder of how we get rid of a fractional coefficient. Let's do another one, this time involving microchips. We got a diagram of a microchip with the following scale. Here we are comparing millimeters of the actual microchip to centimeters. In other words, you can imagine, because microchips are so small, we're actually going to make it larger for the drawing's sake. In this case, the scale is 1/2 millimeter is compared with 5 centimeters. We know it's really 3.5 millimeters. Let's find how long on the diagram. So we go ahead, take our cross products. 1/2 of x is going to be equivalent to 5 sets of 3.5. Now, we don't know what 1/2 x is. After all, x is unknown. But we can multiply 5 times 3.5. And again, I could change that to a mixed number, but why bother right now? Because in order to eliminate the 1/2, let's go ahead and multiply by the multiplicative inverse. Now, in this case, we end up with 1 whole x. And 2's will cross cancel here as well, which means the image is going to be about 35 centimeters big, centimeters on the diagram. One more, we got a Ferris wheel here, 60 feet tall, model is 15 inches. Now, he's going to make a model of the Sky Needle using the same scale, and we know that the Sky Needle is 100 feet tall. Question, how tall is the model? Now, as promised, I'm trying to be consistent, just keep model to actual. So in this case, I will do inches compared with feet. But you could reverse, as long as you are consistent, you could do it feet to inches, and still the cross products will be equivalent. Now, we know that a 60-foot model, a 60-foot Ferris wheel is 15 inches for the model, and we want to keep that equivalent, a 100-foot tall Space Needle ride. Question is, what is that missing piece? So let's go ahead and take our cross products now. I think that's the toughest part, is figuring out how to set up the system. After that point, you guys are going to be in pretty good shape. No idea what 60 times x is, but we do know that 100 sets of 15 is 1500. Divide both sides by 60 so that you can solve for that missing x. Of course, you can reduce by 10 and really just do 150 divided by 6. To find that will be 25. I almost put feet just because I'm in class mode. You guys know I like to make you think a little bit, and you're going to say, wait a second, 25 feet, that doesn't make any sense. That would be because we were asked to find the model height. So that's what I have for now. I'm going to give you an assignment on this. 10 problems should be finished pretty quickly. I would say 20 minutes or less. And then we will continue on with scale factors, kind of sort of 1.5 lessons in one day. We'll see what we can do.